do an example together of kind of how you'd be given mass spectrometry. You know how that works, okay? So, let's read this. A particular lithium sample contains 2 isotopes. These isotopes are singly charged in an ion generation and acceleration chamber. Just like that video was talking about with it can have different isotopes. Since individual atoms are ionized at different points in the acceleration chamber, their speeds vary when they enter the velocity selection chamber. In the velocity selection chamber, the electric field is given and the magnetic field is given. So that's talking about this space right here, the velocity selection chamber. So that's like the accelerator, if we were to think about this. And here would be like the separator or the deflector. So we see deflection happening. Okay. The velocity selection chamber allows ions of certain speed to pass through undeflected. The beam of undeflected ions then enters the ion separation chamber where the magnetic field is this and splits the beams in 2. Beam 1 has a curvature radius of 0.13 meters. Okay. Oh, sorry, I misplaced this one. This is the accelerator. Because that's where we have the acceleration. And this is just selecting a very specific velocity to go through the separator. Sorry about that. Okay, so now we're being asked to find the speed of the undeflected ionized lithium ions as they leave the velocity selection chamber. So what we're asked to find is like V right there, okay? Not V over here, but V right here at the end of that. So because of that, we need to use the information given here. We won't be using this information of magnetic field because it hasn't even gone through that magnetic field at this point. Okay? So we're trying to find speed, so V is equal to question mark. We're given information at that point about our V perpendicular is 1.5 times 10 to the negative 3 Tesla. And we're given our electric field strength is 5.95 times 10 to the 2 Newton coulombs. So I'm just going to do this with a little bit more space here. So again, since we're given information about that it's, so here we can't say that FC is equal to FM because it's not going through a circular motion at that point. So we say FE is equal to FM because it's passing through undeflected, right? So it's not accelerating up or down. So we can say FE is equal to FM for this question. And then, so we expand this to E times Q is equal to Q times B perpendicular. Okay. We can cross off our Q's. We want to solve for V. So then V is equal to E over B. So then our V is equal to 3.83870 meters per second. So to sig digs, that's 3.84 times 10 to the 5 meters per second. So then that's, in the multiple choice options, that's answer B then. Okay. So then there's a second question for this. It says, for numerical response. The mass of a lithium ion beam in beam 1 expressed in scientific notation is what? Okay, so now we need to take, it's asking us the mass of the lithium ion. Well, we need to consider that at this point we can set Fc equal to Fm. Okay, this point we said Fe is equal to Fm. So because we need mass, we need a formula that has mass in it. So in order to do that, we have to consider what the lithium ion is experiencing now in this point, because this is where it's experiencing that circular motion. So in order to use Fc, we have to use this information now. Does that make sense? Yes? Yeah? Okay. So just as long as, but the velocity that I can use is this same velocity that I just found out, because it's coming into here at that velocity. So I can use that velocity that I just found in this formula that's coming up. So now the next part of this is where we're trying to find m. So we can say Fc is equal to Fm. Fc is m times b squared over r is equal to q times b perpendicular. These b's cross out, and I'm left with m times b over r equals q times b perpendicular. I want to solve for m, so I'm going to rearrange for that. So m is equal to q times b perpendicular times r divided by b. So again now, I have to use the b perpendicular that's in the ion separation chamber now, because that's where it's experiencing that circular motion. So now m is equal to 1.6 times 10 to the negative 19. How did I know to use just one elementary charge? Because it's a lithium ion, and lithium is Li plus 1. It's just one charge. It's a positive charge, but yeah, it's plus 1. Times by my B perpendicular in that ion separation chamber is 0.185 Tesla, times by the radius that it gave me, which is 0.131 meters, all divided by the speed that I just found there. So I'm not going to use the abbreviated one. I'm going to put in all digits. I'm not going to use the rounded option. So your mass, you should get 1.10 times 10 to the negative 26. Now, it asks us to put in, it says A point B times 10 to the power of negative CD. So then our answer would be 1.0 times 10 to the negative 26. So A is 1, B is 0, 2, and 6. So your numerical response answer is 1026. Pardon me?
The mass of lithium ion being 1 expressed in scientific notation.
Oh, sorry. I preferred, I should have put this box over top of it. Read this box for how to answer it. Thanks for pointing that out. I meant to put this on top of it, but it printed out both options of how to answer. Okay, so now there's a couple more questions there.